Alright, Logic fans, welcome back to our second video on section 1.3. We're going to continue jumping right into some slightly more difficult things that occur when we begin mixing, right, the wedge and the ampersand along with the negation, okay? So here's an example I've arranged for you. Go ahead now and see if you can't translate these sentences 1, 2, 3, 4, 5, 6, 7 into ordinary English. Pause now. All right, hopefully you've had a chance to go through this, but not A, once again, is probably the simplest one. And again, this just says A is false. It says that it's not the case LeBron is the greatest. It's false that LeBron is the greatest, okay? 2 here is interesting. It says either A or it's not the case that B. So either LeBron is the greatest or it's not the case that gravity obeys an inverse square law, okay? Contrastively, 3 says either A is false or B is true. Alternatively, either it's not the case that LeBron is the greatest or gravity obeys an inverse square law. Similarly, 4 says either A is false or B is false. At least one of A and B is false. Okay, so either LeBron is not the greatest or gravity does not obey an inverse square law. Okay. Similarly, basic sort of similar structure here, but this time with and. This says A is true and B is false. Alternatively, LeBron is the greatest and gravity does not obey an inverse square law. Okay. 6, A is false and B is true. So it's not the case that LeBron is the greatest and gravity obeys an inverse square law. Okay. And similarly, both A and B are false, right? So notice this one said that at least one of A and B is false. Either A is false or B is false. This says both A and B are false, okay? So it's kind of a really interesting situation, all right? But we can imagine some more complex sentences. So for example, let me throw one at you. And again, we're going to be looking at the proper use of parentheses in sections 1.7 and 1.8, so stay tuned for that. But just let me point this out to you here. Go ahead and see if you can't translate that sentence into ordinary English, and let's do this one as well. And you've never seen the parentheses before, but just throwing a little bit of a curveball at you. And again, we're going to talk about this in future sections, but go ahead and just give it a try. Okay, so hopefully you've had a chance to look at this, but this said, the parentheses are supposed to indicate that you take this whole thing here as one unit, and it's saying it's not the case that that whole unit is true. Okay, so it's saying it's not the case that either A or B, right? It's not the case. So if you imagine it without the tilde here, it's a little trick I use sometimes. Okay, that says either A is true or B is true. This says that's not true. Right? It's false that either A or B is true. So another way of thinking about that is like saying they're both false. Right? It's not the case that either of them is true, is like saying they're both false. So this sentence here is logically equivalent to this sentence here. And again, that's something we're going to be able to prove later. It's called De Morgan's. For those of you that might be familiar with that. If not, we will be going into all of that. But yeah, 8 and 7 are logically equivalent. Importantly, 8 is not logically equivalent to 4. Okay, these are not logically equivalent because this says it's not the case that this disjunction is true. It's not the case that either A or B. This says, at least one of A and B is false, possibly both. But this says it's not the case that either of them. In other words, both of them are false, guaranteed. Whereas this just says at least one of them is false, so they're not quite the same, right? So these do not mean the same thing. So you can't just sort of take this negation and distribute it through like you would in mathematics because we're thinking about different things. This isn't multiplication, okay? This is disjunctions and negations, all right? Now you can distribute it through this way, provided you switch the or and the and, okay? Similarly, with 9 turns out to be logically equivalent to 4. Okay, And importantly, 9 is not logically equivalent to 7. Okay, so 9 says it's not the case that this conjunction is true. So if we imagine this without the negation, it says both A and B are true. With the negation, it says that's not the case. It's not the case that both A and B are true. In other words, at least one of them is false, which is this. Okay, so that's sort of what's going on with the parentheses. And again, we're going to be doing a much more detailed treatment of that in the future. And in fact, if you're having a little bit of questions about some of the, maybe an ambiguity with disjunction in particular, stay tuned for section 1.4 where we do advanced disjunctions and advanced conjunctions. And that's really going to flush a lot of things out for you about them. Okay. Okay. So the very last thing we have to introduce in section 1.3 is the notion of a propositional variable as opposed to a propositional constant. And again, we will cover the relationship between the two in depth in sections 1.7 and 1.8. But the basic idea here is that we've got a new symbolic device, okay, and they are the lowercase letters of the English alphabet. We can use any lowercase letter. Typically, we use P, Q, R, and S by long-standing tradition and convention. So, but we can add the subscripts P sub 1, P sub 2 if we need more of them. Typically, we'll avoid using the lowercase v only because we're using that for disjunctions. So just to avoid confusion, we're not going to use v for that so that you're always assured when you see a v, it's a wedge, okay? And the big question is okay, what do these stand for? Well, we're going to get into all of this, but as an introduction, the idea is that the variable, like a mathematical variable, can sort of stand for anything. Okay, in particular, it can stand for any kind of sentence that we build up from the propositional constants, the negation, conjunction, disjunction, and also when we do the arrow and the tribar too, we can throw those in there. But it can stand for any proper combination of these symbols. So let's do an example to give you the idea. Okay, so in this example, I'm trying to emphasize that these lowercase guys can stand for any combination of this stuff. So, for example, suppose the value of P was A, the value of Q was B, and the value of R was C and D, and the value of S was E or F. Okay, my question for you is, can you translate these sentences? Okay, can you translate these sentences into the capital letter sentences that they stand for? So let me give you an example of what I mean together. So let's suppose that I said, translate this sentence. What I want you to do for R then is you would write down C and D, and you can have the parentheses on it if you like. Okay, like that. You would write down that one for R. Similarly, if I had written down not S, or not, let's do not R. Okay, if I had written down not R, then what I would want you to write down is it's not the case that R, which is C and D, you would write down that. Okay. So the idea is that these things can stand for any big combination of the capital letters with and, or, and nots embedded in them. Okay, so go ahead now and see if you can't translate 1 through 7, and we'll come back and do them together. Pause now. Okay, so hopefully you've had a chance to do this. Let's Okay, so let's go through these together. So number 1, for P and Q, you're just going to have, the value of P is A. So you're going to write down the A, then you're going to write down the ampersand, and then you're going to write down the Q, which is B. Okay, and this is what we're looking for here. And so the idea is you're using P to stand for any combination of these things, okay? And in this case, it's the really simple combination, just A all by itself, all right? But we get a little bit more complex with this one because now we've got P or R, and so P is just the A, that part's easy. Then we got the OR, and this is this OR right here. And then you've got the R, which is C and D, so it would be translated to this thing right here, okay? And notice that in this case, R is standing for a much more complex combination of this stuff than than just P or Q is, where P is just A and is just B, and that's possible. But you can also have these much more complex things, and you can have, you know, a really complex thing like that too if you wanted. Okay, so that's the idea of a propositional variable. It can stand for anything in the same way a mathematical variable can. Okay. So not P is just going to be not A, easy. So you write down the not, here's the not, then you write down the P, which is the A. So for S, you're going to write down the not, and then you're going to write down whatever the value of S is, and it's that thing, okay? So moving along, you're going to write down the R, which is this whole thing, C and D, then you're going to write down the and. This and is right here, it's this one, okay? And then you've got the S, which is here, okay? And then for this case, you know, it's the exact same thing as 5. So you just transcribe this, but it was not S, so you're going to add the negation to the S there, okay? And that's the basic idea. Let's do this last one together. So what we're going to do is we're going to write down the P thing, which is right there, okay? Then we're going to write down the Q thing, which is this thing, okay? Then what we're going to do is we're going to come over here and we're going to have the not, and we're going to have the R. And the R is a little bit more complex, but it's just going to be this thing. So we'll go ahead and slide that right in there for the R, and it's going to look like that, okay? And that would be the answer to 7. Now, we're going to have a whole lot more to say about propositional variables. I just want you to have the intuitive idea of what they are. The idea is it could stand for any combination of these, and that's the basic concept that you need. And we're going to be getting into all of that and the relationship between these lowercase and these uppercase things in 1.7 and 1.8, okay? And that's going to be absolutely crucial material for us. Okay, so that's it for your first introduction to symbolic logic. We're going to go into a little more detail on the ands and the ors and the negations as well in the next section on 1.4, which is advanced conjunctions and disjunctions, and you can learn how to use them to count, which is a really, really cool application. All right, logic fans, we'll catch you on the next video, and keep practicing. Make sure you're doing those exercises.